Welcome back, friends. In today's session we are going to continue with our topic of gaseous exchange and respiration, and here I am Dr. Mlelwa from University of Health and Allied Science. So today we are going to continue with the part of metabolic rate, and if possible I will discuss also the part of respiratory quotient. So what do we mean when we are talking of metabolic rate? What does it mean when we are talking the concept of metabolic rate? So metabolic rate, we are saying that as respiration is directly involved with most of the metabolic activities within the body, so it is a measurement gives a relative accurate indication of the metabolic activity. Kwa hiyo respiration ambayo tunachukulia kama kuna internal and external. Nilisema internal respiration is how glucose is metabolized in the cell, but external respiration, the rate of uptake of oxygen and removal of carbon dioxide, that is external respiration. So when we are talking of external respiration, we are talking of the process of gaseous exchange, where the internal respiration, the process by which a cell takes glucose and tend to metabolize it to produce energy. Kwa hiyo sasa internal respiration pia inategemea rate ya external respiration. Na ndio maana, for example, if a person is exercising, that means the muscle they require more ATP for exercise, and because the muscle they require more ATP, yule person manake ataongeza the rate of internal respiration, that is metabolism of glucose to release ATPs. Lakini because the metabolism of glucose to release ATP, if we want to produce many of the ATPs, glucose must be metabolized by aerobic respiration. So the need for oxygen, which is used in aerobic respiration, itasababisha we human being respire faster. So ata respire faster in order to get more oxygen which can be used in the aerobic respiration, and then at the end of the day yule mtu ataweza kufanya exercise vizuri without muscle cramp, and then at the end of the day mtu atakuwa yuko vizuri. Kwa ninachozungumza ni nini? Ni kwamba rate of internal respiration depends on rate of the external respiration. So when the rate of internal respiration, which is metabolism, increases, also the rate of external respiration, which is gaseous exchange, also increases. So we can measure the rate of respiration, and by measuring the rate of respiration, it determines the rate of different metabolic activities in the body of such kind of living organism. So what we are saying ni kwamba metabolic rate can be calculated by measuring the rate of oxygen consumption, ambayo hiyo ni external respiration. So tuna measure organism ana consume how much of oxygen. Tukimeasure tunakuwa tunajua pia rate ya metabolism, because a consumption of oxygen is direct proportional to the rate of metabolism. So small mammals, they have higher metabolic rate than the large mammals. Why small mammals they have higher metabolic rate than the large mammals? The major reason behind here with the body size is the surface area to volume ratio. Small mammals, they have high surface area to volume ratio, and hence it is easier for them to lose temperature. So in order for them to maintain their body temperature at constant level, because some mammals, they are homoeutherms, they are able to maintain their own body temperature. So in order for these small mammals to maintain their body temperature at constant level, manake they require a high rate of metabolism. Kama ambavyo tulisema kwamba katika process of respiration, au kama ambavyo tutaenda kudiscuss mbele, katika process of respiration, energy produced by the reactions of respiration, some of it is stored in form of ATP, but the remaining energy, it is dissipated in form of heat. So that remaining energy which is dissipated in the form of heat, it is very important for homeostates to maintain their body temperature. That's why at low environmental temperature, homeostates tend to increase the rate of respiration in order to get more heat. So small mammals, they have large surface area to volume ratio, and hence they lose heat faster. So in order for them to maintain their body temperature at constant level, they must have a higher rate of respiration or a large oxygen consumption as compared with the large mammals. So here we have the graph. Hii graph iko kwenye biological science book, lakini this graph illustrates the rate of respiration in different number form of organism. Kwa unaweza kuiona tu kwamba how the graph appears, rate of respiration in different number of organisms. So you can see from the graph kwamba huyu hapa ni mouse, huyu ni rat, huyu ni rabbit, huyu ni dog, human, horse, elephant. So this is the metabolic rate per millimeter cube of oxygen per gram. So the unit of this metabolic rate is millimeter cube of oxygen per gram per hour. Kwamba millimeter cube of oxygen ni how much of oxygen, volume of oxygen consumed. Then gram is the mass, then hour is the time. So upward measure volume of oxygen consumed per mass of the organism, then per time. So unaweza kuona kwamba hizi huku zinazidi kupanda mpaka kule ambako ni 2000, lakini huku pia ni body mass. Kwa huku ni oxygen consumption, huku ni body mass. So ukiangalia unakuja kuona elephant ambaye ana body mass kubwa, kwa sababu ndio mass, ana about 1 million grams na zina exceed hata hizo. Elephant yeye anakuwa na low oxygen consumption as compared with the mouse. So mouse na rati hao wote ni panya, lakini tu wanatofautiana tu aina ya panya, lakini wote ni panya. Rabbit ni sungura. Tukapo tuna dog ambaye ni mbwa, tuna human, afu na horse ambaye ni farasi. Kwa unaweza kuona the body mass increases, the rate of metabolism decreases. So metabolic rate of animals calculated per gram body mass plotted on the logarithmic coordinates. This graph is plotted in the logarithmic coordinates. So now let's see some of the facts behind this graph. As I told you that mouse have the large surface area to volume ratio, thus will lose more heat, and thus at the end of the day atapelekea in order to maintain its body temperature lazima awe na higher rate of metabolism. So now let's see the next page. Now from what we have discussed in the previous page, and we have ended with that graph. Now if the question come, the volume of air exchanged in the alveoli is in fact less than that of the pulmonary ventilation. Suggest why this is the case. Hili swali liko kwenye BS. The volume of air exchanged in the alveoli is in fact less than that of the pulmonary ventilation. Suggest why this is the case. Kwa hiyo kinachozungumziwa hapa ni kwamba air inayofika kwenye alveoli, yani sio yote inayokuwa exchanged. Manake air tukivuta toka huko nje, kuna nyingine inapita huko kwenye bronchi, inapita kwenye bronchioles, mpaka nyingine inafika wapi? Kwenye alveoli. Sasa air inayofika kwenye mapafu, manake nyingine inakuwa kwenye bronchi, kwenye terminal bronchioles, lakini air inayokuwa exchanged ni kidogo. So the volume of air exchanged in the alveoli is less than that of the pulmonary ventilation. So pulmonary ventilation volume yake ni kubwa, kati air inayokuwa exchange ni ndogo. Why? It is because of the dead space air. Dead space air ni hewa yote ambayo haifanyi gaseous exchange. Yani umevuta oxygen, haujafanya exchange oxygen yote, imebakia nyingine. Ile oxygen ndio back tunaita dead space air. So hiyo ni question number 1. But question number 2 unaweza kuona hapo. Kwa mfano wamekuuliza why metabolic rate of small mammals is higher than that of large mammals. Why metabolic rate of small mammals is higher than that of large mammals. So na B wamekuuliza how can you compare the metabolic rates of mammals of different sizes. Kwa kama tulivyosema kule mwanzoni kwamba metabolic rate of small mammals is higher because these they need to maintain their body temperature. They have the large surface area to volume ratio ambayo ana lose heat. Kwa kiruzi heat wanahitaji ku maintain their body temperature. So what we are saying about these mammals ni kwamba tunasema hivi kuhusu hizi mammals. Smaller mammals have a large surface area to volume ratio from which heat can be lost and therefore must use up more oxygen in order to maintain a constant body temperature. So the fact behind is the large surface area to volume ratio, and in order to maintain their body temperature they must use up high amount of oxygen so that to maintain their body temperature. While large mammals have small surface area to volume ratio, hence heat cannot be lost easier. And if we want to compare the relative metabolic rates of small and large mammals, we are saying by relating oxygen consumed per gram of the body weight in a unit of time. So if we are using the measure of respiration iwe ni gram, oxygen consumed per gram, tunaweza kujua kwamba UP anaweza ka consume zaidi. So by definition, metabolic rate is the measure of energy released by the body. Metabolic rate is the measure of energy released by the body. Measure of energy released by the body is what we define as the metabolic rate. So now from there, let's go to discuss about the concept of basal metabolic rate. The concept of basal metabolic rate. So, as we have said, metabolic rate is the measure of energy released by the body. So, what does the term basal metabolic rate means? Tunavyosema basal metabolic rate ni ile rate ya metabolism inayohitajika ku maintain the basic functions in the body. Kwa mfano, mwanadamu hawezi akaishi bila moyo kudunda. Hawezi akaishi bila moyo kudunda, hawezi akaishi bila kupumua. So heartbeat inakuwa ni basic activity of the body. Halafu kupumua, gaseous exchange ni basic activity. Kwa hata mtu tuseme alale 444 ana koroma we udenda unatoka ajerewi, lakini bado lazima huyo mtu atakuwa anapumua, heart rate inaendelea. So basal metabolic rate ni ile rate ya metabolism ambayo tunaassume organism anakuwa completely rest, nothing is functioning. Yani huyu mtu mawazo yake anakuwa ametulia, akili imetulia, mwili umetulia, completely rest. That's what you call the basal metabolic rate. It's the rate of metabolism required to maintain basic activities in the body such as heartbeat and gaseous exchange. So the term which describes the basal metabolic process needed to keep a human alive is basal metabolism. Kwa hii ni energy inayotakiwa kumfanya mwanadamu aishi. Maana energy ikiwa ndogo ya hii mwanadamu atafanya anakufa. So the basal metabolic rate of an organism is the minimum rate of energy conversion required just to stay alive during complete rest or sleep. Complete rest or sleep. Energy inayotakiwa wakati ule ndio inatakiwa basal metabolic rate. Or in other words, you can say basal metabolic rate is the amount of energy needed to maintain vital activities of life. Vital activities of life manake ni shughuli muhimu za maisha. Vital activities of life such as breathing and beating of the heart, and in some animals maintenance of the body temperature. Kwa sababu gani? Kwa baadhi ya animals body temperature kishuka ikiwa ndogo sana zinakufa. Kwa hiyo ndio tunaita basal metabolic rate. Inahitajika ku maintain the vital activities of the life. More especially hapo tunazungumzia hizo vital activities, tunazungumzia nini hapo more especially? Tunazungumzia vital activities, we are talking of kwanza ni breathing. One among the vital activities ni breathing. Yani tunazungumzia basal metabolic rate. Sima ujue vital activities kuna breathing na nini? Beating of the heart. Beating of the heart. Kwa hizi ni examples of the vital activities tunazungumzia. and in some animals, maintenance of body temperature. So the rate of metabolism required to maintain these activity, required for the body to perform these activities only, not other activities, is what we call the basal metabolic rate. Basal metabolic rate. So as we have said that basal metabolic rate is the rate of metabolism when an organism it is at completely rest. So we must have some of the conditions which must be obeyed first before start measuring the basal metabolic rate of an organism. So different organisms will have different basal metabolic rate depending on their rate of performance of different metabolic activities. But as I've said, because of their different rate of performing different metabolic activities, so different organisms will have different basal metabolic rate. Lakini nachokisema ni kwamba before the basal metabolic rate of a human subject is measured, they undergo a standardized rest period of 12 to 18 hours, physical and mental relaxation. Kwa hiyo mtu analala kwenye physical, lakini pia anatakiwa afanyiwe mental relaxation, yani kwamba akili yake tuhakikishe pia haifikirii, sababu akili inafikiria inaweza kutumia energy nyingi, and then tukapima tukajua ni basal metabolic rate, kumbe ni mtu alikuwa anawaza sana. So no meal is eaten during this time, masaa 12 hadi 18 mtu hali na undergo physical and mental relaxation. Kwa at the end of the day mtu ndio tunakuja kumpima basal metabolic rate. This ensure that the alimentary canal is empty before measurement are taken. The basal metabolic rate varies with age, sex, size, and state of health of individual, and is clearly correlated with body surface area to volume ratio. So basal metabolic rate ina vary kulingana na factors hapo kama ambavyo tutaenda kudiscuss, lakini pia basal metabolic rate inategemea kwenye body surface area to volume ratio, kwa sababu one among the basic activities for homeostasis is maintenance of the body temperature. So among vertebrates classes, apes, which are birds, and the mammals have the highest basal metabolic rate. Why apes? Because apes and mammals kwanza they are homeostasis, lakini pili for example apes they require high amount of energy for flying, mammals they require high amount of energy for different exercise and things like that. So apes and mammals they have a higher basal metabolic rate. This is because they are endothermic, which means they warm their body mainly with heat generated by metabolism. So the major reason why apes and the mammals, kwa nini birds and the mammals, it is because they warm their body by heat which is generated mainly by metabolism. Reptiles and amphibians and various classes are ectothermic, which means they absorb most of their body heat from the external environment. And if they absorb most of their heat from the external environment, that means they will have the slow basal metabolic rate, because they do not require high amount of heat. They do not require faster rate of respiration for them to generate heat. Now let's move to factors affecting the basal metabolic rate. So as we said that basal metabolic rate is affected by different factors, and here we are discussing the basic factors which affect basal metabolic rate. So our first factor is body size. The smaller the mammal, the higher the basal metabolic rate. Kama ambavyo tumediscuss kwamba small mammals they need to maintain their body temperature, and thus due to the large surface area to volume ratio they lose temperature easier. So in order to maintain their body temperature, they must have the faster basal metabolic rate or the higher basal metabolic rate, so that to make sure that temperature does not fall below the normal body temperature. The second factor is the surface area of the body. Ambayo the larger the surface area, the higher the basal metabolic rate. So the larger the surface area for a given weight, the greater heat loss, and hence the higher the basal metabolic rate. And then from there we have age factor. Children have relatively higher basal metabolic rate for a given weight than adults. The maximum basal metabolic rate occurs at around age of 20 and diminishing slowly as one age or as one grows. So children, they have higher basal metabolic rate simply because one among their basic activities is growth. So the need for growth and the need for synthesis inasababisha wao wana higher metabolic rate as compared with the adults. And at the age of 20, it is around adolescence. So if adolescence starts from 14, and so it is around adolescence, and adolescence is where we have the maximum rate of growth. From there, then the basal metabolic rate diminishes as one grows. The level of hormone thyroxine, which control metabolism. Thyroxine hormone, as we discussed in coordination, that it tend to control the metabolism of glucose, and more especially it is glucose. However, it also controls metabolism of fat and proteins. So if we have a higher level of thyroxine, then the metabolic rate will also be higher. Then you have sexy. In sexy, male have higher metabolic rate than female because male are more muscular than female, and not only being more muscular, but also because male they perform tough activities, so though they lead to processes like hypertrophy of the muscles, and thus increasing the energy requirement. From there we have the type of activities an individual is doing. Kwa hiyo especially hapo tutakutana kwamba na activities ambazo wengi wanafanya kama zilikuwa energy, manake mtu pia atakuwa ana high basal metabolic rate. So in the next session we'll be discussing about the concept of respiratory quotient. Respiratory quotient, it is significant and it is uses. Don't forget to subscribe the channel and to share the link of this channel to your fellow students. If you need notes, you may contact me. My contacts are here, so you can contact me, and then you can get these notes in an easier way. Also, we have other notes of other topics such as nutrition, coordination, and cytology. They are present in the Kipaji app, so you can download the app, and then you can access the notes. They are sold at very low cost, and you can continue learning, and they wish you nice performance in your subjects. Thank you.